249, I'm given my f of x is this. It says square root. I'm just going to raise it to the half. And then what rule do I use to take the derivative? I'm going to use the general power rule, and then inside that I'm going to use the quotient rule, right? So if I take the derivative, what do I do with that half? Bring it down front. And then this just stays the way it is, and then it's going to get raised to the what? Negative a half. We subtract 1 from our exponent. Now what do I have to remember to do? The derivative of the inside, right? So derivative of the inside here, low d high would be what? What's the low? X, and then d high is 1, right? So low d high would be x times 1 minus high d low, and d low is 1 over the bottom squared. And away we go. Then I'm going to just clean up this back parenthesis here. So I still have this half, and I still have this piece here. And then what's going to happen to the numerator back here? X's cancel, so I'm left with negative 1 over x squared, right? So any questions to that point? So now we've got this piece here. And this is the part where you may not have known how to simplify it. But if you just look at this piece here, isn't this x plus 1 to the negative a half over x to the negative a half? And if I want to get rid of the negative a half, what do I do with this? Move it to the denominator, and what would I do with this? Move it to the numerator. So this is equivalent to x to the half over x plus 1 to the half. Do you guys see that? Which is the same as x over x plus 1 to the half. I'm just doing this so I can show you a little trick here. So do you see how this piece here is equivalent to this piece here? So if you have a negative exponent, you can just flip what's inside there and then make it a positive exponent. You see that? So now I have a half times, and this is square root of x over square root of x plus 1. So I'm just going to write it like that. And then this is negative 1 over x squared. And then you just multiply those together. So numerators, I'm just going to have a negative square root of x. And denominators, I have 2x squared square root of x plus 1. So that would be my derivative. And you could simplify it just a little bit, because this is x to the half and this is x squared. So what do you do with those exponents? You subtract them. So this could be written as negative 1 over 2x to the, what, 3 halves, and then square root of x plus 1. So those are equivalent to each other. I'm not sure what the back of the book does there. Okay, now the other part says, describe the behavior of the function when the derivative is 0. Negative 1 over what is equal to 0? Nothing, right? You can't have a number on top and something on bottom and get 0. So this is never equal to 0, so we're just going to say never is 0. So I just rewrote 61. And what do I have to use if I have two things multiplied? Product rule, right? So the product rule, what do? I leave the x alone, right? And then I'm going to take the derivative of this back here. So this back here, what do? You bring the half down.
And then you leave the inside alone.
You leave the 2x plus 3 alone. Leave the inside alone. What are we missing? Subtract 1, so what's my new exponent? Negative a half. And then multiply by the derivative of the inside, which is 2. And then a lot of people just continue from here. What am I still missing? What's the product rule? I have to do the other portion, right? This was just leaving the first part alone, taking the derivative of the second. Now I have to go plus, what's the derivative of x? 1, and then I leave this piece alone. And then here, we can cross off the half and this 2 because they just get multiplied. So isn't this just x over square root of 2x plus 3? You see that? Because this x stays in the numerator, right, because it's to the first, and then this is in the denominator, and then back here I've got plus square root of 2x plus 3. And I'm going to put that over 1. Only if it's multiply. Yep, you guys are thinking multiply here. So now I get a common denominator, and what is my common denominator? Square root of 2x plus 3. So I multiply this by square root of 2x plus 3 on top and bottom. So my denominator is just square root of 2x plus 3. And my numerator is this x plus, and what happens when I multiply these together? So I just get 2x plus 3, and then you just combine like terms. So you just get the 3x plus 3 over that square root. And you could pull a 3 out if you want to in the numerator, but you definitely don't have to there. So this would be my y prime. Okay, so 65, let's get it started here. So to take the derivative of this, I'm using the general power rule, so what do I do first?
Bring the 2 down.
Bring the 2 down, and then what do? I subtract 1 from the exponent. Okay, but what do I still have to write?
You gotta write what you have in front.
The parentheses, right? I leave the parentheses alone. And then it's raised to the first power, so we don't need to write that. And then what do I still have to do? Yeah, so if I multiply by the derivative inside, low, what's d high? Negative 5 minus high, d low, 2x over x squared minus 1 squared. So questions up there? Okay, then I want to clean up this numerator here. So I'm going to distribute this negative 5 through. So I get negative 5x squared plus 5. Does that look okay for this piece?
Yep.
And then back here, the negative and 2x, I'm going to multiply through. So minus 12x plus 10x squared. That looks good. So that's going to take the place of all of this stuff here. And then if I combine like terms, what do I get?
You get 5x squared minus 12x plus 5.
Okay, the 5x squared minus 12x plus 5. And then I still have this stuff. So really I've got 2 times 6 minus 5x times that 5x squared minus 12x plus 5. Okay. And then in my denominator, what do I have?
You have x squared minus 1 cubed.
Yeah, x squared minus 1 cubed. Perfect. Yep, that's just because this is to the first and this is to the second, so you add your exponents. Okay. So this is my derivative. That should take care of it. Is that what it looks like?
I guess you can multiply it out and see if it recancels what you said.